Hello and welcome to The Daily Space. I'm your host, Dr. Pamela Gay.
And I am your host, Beth Johnson.
And we're here to put science in your brain. Today we'll look at a dynamical analysis of the 14 Hercules system that has revealed the existence of two brown dwarf planets orbiting in completely misaligned eccentric orbits. The study also uncovered the possibility of a third brown dwarf that was ejected from the system. Plus, weird ice in Chicago, the ongoing debate about liquid water on Mars, one rocket goes up while a capsule comes down, and in the final segment, we interview Dr. Nicole Colon from the JWST mission. We'll be back with all our stories in just a moment.
We have hit that part of winter where the sun is rising a little later every day, but for many of us, bright blue skies come with the coldest days of the year. It is, in fact, so cold that folks in Chicago are seeing a rare phenomenon out on Lake Michigan: ice pancakes. These round disks of slushy ice form when restless water starts to freeze, but wave motion causes the ice to constantly break and the pieces to collide. Ultimately, like rocks in a river, the crashing ice chunks become rounded. Slight lips form around their edges, where material builds up during collisions and water splashes up and freezes. While ice pancakes are rare on the Great Lakes, they can be found much more often in Antarctica or the Baltic Sea. Now, before you think about waiting out to load up a plate with icy goodness, we have to warn you, these discs are more slush than ice and will completely fall apart unless your spatula is big enough to support their entire 8-inch to several foot wide diameter. So get your biggest spatula, a frozen plate, and head out to the Windy City to get some ice pancakes today. This ice phenomenon may be gone tomorrow.
Just to add to that last story, I feel the need to say you shouldn't eat or drink anything that comes out of the Great Lakes unless local authorities have indicated it is safe. Just don't. While the cold weather pushes through my part of the Midwest, I'm reminded of the landing of the Mars Exploration Rover Opportunity back in 2004. That particular day, it was warmer on Mars where Opportunity landed than it was where I worked in the city of Boston. I was envious of that warm rover and became very close friends with its distant cousin, my electric space heater. While we think of Mars as a sub-freezing desert, the truth is summertime temperatures can soar into the 70s. It's not the temperatures that prevent water from flowing on the red planet, it's the lack of an atmosphere. Without the pushback of air, water molecules will happily go from frozen ice to humidity-raising gas in a single step called sublimation. Scientists held out hope, however, that groundwater could still exist beneath the surface. Not ice, water. In 2018, this hope was thought to be confirmed as a reality when radar return showed a region of high reflexivity under Mars' ice-covered South Pole. In general, radar reflects extremely well off water, and we know that subglacial conditions can allow liquid water here on Earth. But sometimes, when you see smoke, there's just a smoke machine and no actual fire. In this case, the strong radar returns came from a region that detailed calculations said probably shouldn't actually have water. Mars isn't Earth, and what makes sense here doesn't apply there. When a different team of researchers simulated what other regions of Mars would look like in radar if covered in ice, They realized that volcanic plains, with their solidified iron-rich lava, can reflect in ways that look just like what was seen at the South Pole. This research was led by Cyril Grimma and appears in Geophysical Research Letters. Grimma's colleague Isaac Smith reminds us, science isn't foolproof on the first try. That's especially true in planetary science, where we're looking at places no one's ever visited and relying on instruments that sense everything remotely. Space is hard, but it is really amazing that while we can't yet explore Mars in person, we can explore it with robots, radar, and so much more thanks to rockets. And speaking of rockets, next up, Eric Mattis brings us the latest on one rocket that went up and one capsule that came down. Take it away, Eric.
Thanks, Pamela. On January 21st at 1900 UTC, United Launch Alliance Atlas V launched the USSF-8 mission for the United States Space Force. USSF-8 debuted a new variant of the Atlas V, the 511. This version has a 5-meter fairing, only one solid rocket booster, and one engine on the Centaur upper stage. The single solid rocket booster is possible because the nozzle is angled through the average center of mass of the rocket, and the RD-180 main engine has a large gimbal range to compensate for the offset. The 511 variant has always been available, but until now, no payload has needed it. Let's watch the launch.
5, 4, 3. We have ignition and liftoff of the United Launch Alliance Atlas V rocket carrying SF-8 for the United States Space Force.
Now 10 seconds into flight, vehicles begin the pitch over maneuver. Body responses look good.
USSF-8 include two GSSAP, or Geosynchronous Space Situational Awareness Program satellites. Not much is known about the two satellites except that they will monitor objects, including active satellites and space debris, in geostationary orbit. USSF-8 included the 5th and 6th GSSAP satellites. The first 4 were launched on now retired Delta IV medium rockets. Also in rocket news, SpaceX's uncrewed CRS-24 Cargo Dragon successfully returned to Earth yesterday, January 24th, at 21:06 UTC. The spacecraft had undocked from the ISS the previous morning. It returned to the Gulf Coast, landing off the coast of Panama City, Florida. CRS-24 brought back with it some old hardware for refurbishment on Earth, including parts of the station's life support system and a microscope that had been on the station since 2009. The Dragon also brought back science results for analysis from the InSpace 4 and cytoskeleton experiments. After the break, Beth will be back to talk about a weird planetary system with a violent past, and then we'll have her interview with Dr. Nicole Colon from the JWST mission. Stay tuned.
From our solar system and its fascinating science and engineering, we now wander off to a distant star system with a violent past, 14 Herculis. Researchers at the American Museum of Natural History led a study of this particular system nearly 60 light years away from our own, because it has an almost sun-like star and is relatively nearby. It's been studied for over 2 decades, but new data from ESA's Gaia telescope, combined with existing data from their Hipparcos mission, provided evidence for a significant amount of acceleration in the motion of the star. The time difference between the two measurements was about 24 years, and the motions of the star differed by 31 sigma. That simply means that the star's motion is being perturbed by some type of unseen mass. Co-author Dr. Jackie Faraday notes, finding that a star is accelerating when it has a planet is a big red flag that there is science to be uncovered. So the team dug through all the literature they could find on this star and managed to gather 20 years of radial velocity data. Using open source code called Orvara, they combined all the measurements and managed to create a detailed architectural picture of the entire system. And they found 2 planets, brown dwarfs, the mass of 9 Jupiters and 7 Jupiters. They are located 2.8 astronomical units and 27 astronomical units from 14 Herculis, respectively. But their orbits. Oh, their orbits are what makes this story so very interesting. The orbits are eccentric, and that's fine, but they are also incredibly misaligned. Lead author Daniela Bartolez Galiufi explains, if you were to look at these two planets from afar, their orbits would cross each other in an X pattern at the center of the star. The 14 Hercules system looks like the result of a complex game of billiard balls in the sky. In our solar system, all the major planets are aligned in the same plane, what we call the ecliptic, and that suggests they all formed in that first protoplanetary disk. In 14 Hercules, it seems that the planets were scattered by each other, perturbing their orbits, possibly even ejecting a third smaller brown dwarf out of the system. Unfortunately, that now free-floating planet would only have been about 250 to 300 Kelvin, very cold and very small for a brown dwarf. In other words, already difficult to detect when orbiting a star, and now nearly impossible. However, nearly impossible means that there is still a chance, and the Brown Dwarfs in New York City Research Group plans to map as many planetary systems in our neighborhood as possible to try and find more mysteries to solve. This work was published in the Astrophysical Journal Letters, and there's also a fantastic video created by Dayon Desir using the visualization software OpenSpace. We will have links to the paper and the video in our show notes. After the break, I'll be back to speak to Dr. Nicole Colon about JWST and more exoplanetary research. Stay tuned. Of course, we would be remiss to not talk about one of the biggest bits of news in space at the moment. On Monday, January 25th at 1900 UTC, the JWST fired its thrusters for almost 5 minutes to complete the last of its post-launch course corrections. This particular burn inserted JWST into its halo orbit around the Earth-Sun Lagrange point 2 position, about 1.5 million kilometers from Earth. Now, engineers here on Earth will begin the process of aligning all the optics to nearly nanometer precision, which should take about 3 months. Joining us now is Dr. Nicole Colon. Dr. Colon is an astrophysicist at NASA's Goddard Space Flight Center and the JWST Deputy Project Scientist for Exoplanet Science. Her research interests include the discovery and characterization of exoplanets, and she's here today to talk to us about the JWST, its missions, and her own goals in her research using the new telescope. Thank you for joining us, Dr. Colon, and welcome.
Thank you for having me.
So, how did you get involved in this particular mission?
Oh gosh, I'm one of the newer people actually on it. I've only been on it since late 2019 or so. And what happened was Webb is going to basically study everything in astronomy, right? Everything in the universe. But a quarter of its time will be spent being extrasolar planets or planets that orbit distant stars. So they needed somebody basically on the team, who was an expert specifically dedicated to that topic to make sure that we were ready to do exoplanet science with Webb. And that's basically where I came in, in the final inning of the game, but still, an important step.
So speaking of the final inning of the game, how were these couple years for you? A little stressful?
Well, I mean, it's exciting, but, it's stressful. Yeah. Just because, this massive giant telescope was launching, right? That we've never launched anything like this before. So I think there's always going to be a level of stress when you're doing something brand new. But I think the excitement usually tended to outweigh it because, we knew that big things are going to come. And, every day it's like just all the feelings almost. But in a good way. Yeah.
Walk us through a little bit how Christmas Day was for you.
Yeah. Oh gosh, Christmas Day. I mean, it was pretty neat for one thing because I actually got to be part of the live broadcast that morning. And so we were airing from NASA Goddard and we were talking about Webb and it was really exciting. And, I was very nervous because it was just a big day, of course. But we also wanted to share Webb's story, right, with the world. And
Hmm.
so it was a level of excitement, and like I didn't really sleep much the night before. So, it was there was a lot going on, but it was strange because it all happened so fast. And then, I got home by like 9 a.m. And then I was like, did it really launch? Did it really happen? So it was almost a state of disbelief as well.
I think we all sort of felt that way, so I understand.
Yeah.
I honestly did not get up for that because it was way too early in the morning. So I was just sort of hoping that when I woke up, the news would be good.
Hmm.
How have you been working over the last month or so as we've worked on reaching this L2 halo point?
Hmm. Yeah, I've been able to be a part of the activities that are happening at the Mission Operations Center, where we're controlling web and sending commands. So I've been able to be one of the people supporting that. And so even actually just yesterday, I was on shift there during this final burn that we had that got us into the final orbit for web. Around the L2 Lagrange point. And so it's been really exciting, being part of NASA where I can support these activities and to, be there live when things are happening, and, hearing basically on the loops, like they're talking, oh, go for burn. And I'm like, it's happening. So it's just really neat and a really big learning experience too. I'm learning a lot.
That's great. Uh, so I know like the next 3 months are really going to be heavy on the engineering side as everything gets set up and all aligned and all of that kind of thing. What are you going to be doing over the next 3 months while we wait that for that next big milestone?
Yeah, our team at NASA is still going to be basically supporting some of these activities that are happening at the control center, the operations control center. And what we basically do is, we're there to provide like additional eyes and ears. If basically they need any input from NASA, a lot of these people, they're all engineers, right? Most of us are scientists, so it's not really our time yet, to shine in a way, because the science instruments need to be turned on. But um, for example, though, once those science instruments come on, we'll be even more heavily involved. And so,
Mhm.
even though the next 3 months are focused on the mirrors, there's a lot of preparatory work still going on behind the scenes to get the science instruments ready to kick off and start, taking data to test them out and all that. So, yeah, we'll be involved in different levels of activities there.
All right, so that's JWST. Let's talk now about your research because
Mhm.
I want to know what you're working on specifically and what your hopes are. So let's start with what is your specialization? Obviously, I said is characterization and discovery of exoplanets. What exactly are you working on? What are you looking forward to?
Mm. Well, I have a couple projects in the works, but always, looking down the road too. So one thing I've done in recent years is work on the TESS mission also, which is the Transiting Exoplanet Survey Satellite. And so
Mhm.
that one is designed to find exoplanets around other stars, especially bright nearby stars. And so um, I basically have helped out with several different discoveries from that, and I'm trying to, or I am actively like continuing working on different projects. I have like some students, for example, who are leading discovery papers, which is really exciting. So I get to support them and help them make new discoveries. And what we're trying to do too, all of us we're trying to find the best targets for web to observe as well, because it's yes, we want to discover more planets, but it's about then learning about what they're made of. And so that's my ultimate goal is, you know, what are their atmospheres made of? How much water do they have, or carbon dioxide, things like that? And how does that all tie back to knowledge of planets in our own solar system? So that's something that Webb will be able to provide us. And so a lot of like the projects I'm active on now are kind of prepping for that, web science and web observations that can be done.
How can you give just a will you please give a brief rundown of how Webb is going to help characterize exoplanetary atmospheres?
Yeah. So there's two main ways, but very short. Webb will be taking direct images of, and so we'll see a fuzzy dot essentially. Once you block the light from the star, you'll see a fuzzy planet there. And it's fuzzy only because they're far away, not because Webb isn't powerful. I should say that. And then the other way Webb can study planets is by looking at what happens when a planet goes in front of a star. And then when the planet has an atmosphere, the atmosphere blocks extra light from the star, essentially. And both with that method and the images, we can take the light that we're getting and decipher it, disentangle it, like spread it out like a rainbow, essentially. So that way we can tell, okay, at this peak in light, we're seeing absorption from water, essentially. Things like that are what Webb will be able to do.
And of course, the big question I think a lot of people want me to ask is this going to help us figure out if a planet is habitable?
Well, we're going to try. So there's a couple planets that Webb will be observing that are around the size of Earth and have a temperature around the same temperature as Earth. So when you put those two together, we think that they're potentially Earth-like, but at the same time, they orbit stars that are very different than the sun. So they're definitely not direct analogs to Earth. That being said, there are current closest example, and we need to start somewhere, right? So is going to start exploring their atmospheres from afar and seeing if they do contain some of the basic kind of building blocks of life, which include some water and then some other like hydrogen, carbon molecules, things like that that like I said, we are the building blocks of life as we know it, at least. So Webb will start kind of diving into that in this first year of science.
Fantastic. We look forward to having you back when some of that science starts rolling in. So it has been great having you here today, Dr. Colon, and thank you again for joining us. To all of you watching, this conversation ran longer than we can air here on Now Media. You can catch the interview in its entirety on our website, dailyspace.org.
While you're there, check out our show notes to find more information on all our stories, including images. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.